Welcome to the second part of bonding. In the previous video, we looked at introduction and ionic bonds. In this video, we're going to take a look at covalent bonds and metallic bonds. Let's get started. So what is covalent bonding? Covalent bonding is also known as molecular bonding and basically involves the sharing of the outermost electrons between non-metal atoms. So unlike ionic bonds, covalent bond is all about sharing. Ionic bonding, it was one atom donating, another atom receiving. Also, ionic bonding involved metals and non-metals. Covalent bonding is only between non-metal atoms. A covalent bond consists of a shared pair of electrons, and it is formed between non-metals which share one or more pairs of electrons. So there are two important facts where we can get from here. The first is a covalent bond consists of a shared pair of electrons. So a single covalent bond is made of two electrons which have been shared by two atoms involved. So the latter part of the sentence says it is formed between non-metals which share one or more pairs of electrons. So even though only two electrons need to form a covalent bond, more than one covalent bond can be formed when atoms share more than one pair of electrons. So covalent bonding results in the formation of what are called covalent compounds, which are also known as molecular compounds. Covalent compounds are usually molecules. What is a molecule? A molecule is just the smallest particle of an element or compound that exists independently. By independently, it means it is in a free state. As a result of sharing electrons, each nonmetal acquires a completely filled outermost shell. Remember, the whole point of bonding is to be stable. To be stable is to have a complete filled outermost shell. So by sharing electrons, atoms involved become stable. Examples of covalent compounds include hydrogen, carbon dioxide, ammonia, and water. So just as a reminder of what nonmetals are, on the periodic table, elements in group 8 or group 0, group 7, group 6, group 5, and some in group 4 are nonmetals. So these ones are the ones that form covalent compounds. So we're going to study how a covalent compound is formed. We're going to use 2 or 3 examples, or maybe 4, so that you have a full understanding of how covalent compounds are formed. By the end of this part, you should be able to, if you have been given 2 elements, and if you have been told that a bond is formed between them, you should be able to explain or to show how a bond is formed. We're going to start with hydrogen molecule. So the chemical formula for hydrogen molecule is H2, and the electron configuration of hydrogen is 1. By the way, H2 means there are 2 hydrogen atoms that are involved in this bond. So the electronic configuration for one hydrogen atom is 1 and another is 1. Hydrogen has 1 shell. This means that it needs only 2 electrons to be stable because it is the K shell. And hydrogen, in this case, obeys the duplex law. So now, how is a bond going to be formed between these two? So since this has 1 and this has 1, each is going to contribute to the bond. In short, this hydrogen atom is going to share its 1 electron, and this one its 1 electron. So each of them is going to have 2 because they have shared. So to illustrate what I mean by this, we use this write-up to show formation of hydrogen bonds. So we have hydrogen here and we have hydrogen here. These dots represent electrons. So each of the hydrogen atom has contributed 1 electron to the bond. And now we have a pair of electrons, which is 1 covalent bond. So this hydrogen assumes that it has 2 electrons, and this hydrogen assumes that it has 2 electrons, and therefore they are stable. So usually we don't, instead of showing electrons, to show a bond, the 2 electrons are replaced by a single line, which is or which represents a covalent bond. So this is a covalent bond. Whenever you see this in chemistry, just know that it is a covalent bond. So in summary, each hydrogen atom has one electron. When the two hydrogen atoms combine, they share electrons. So here is a balanced chemical equation of how this molecule is formed. Hydrogen plus hydrogen forms hydrogen molecule. So a visual representation of what happens is like this. So there are two important things I want you to note here. The first is when we're doing with covalent bonding, we only show outermost shells. Of course, hydrogen has one single shell, so there are no inner shells. But for other atoms which have more than one shell, you only show the outermost shell because it is the one that is involved in bonding. So in this case, then the other fact I said too, the other fact is in ionic bonds we were showing the formation of ionic bonds by x's, but here we are going to use both notation, dots and x's, to show electrons. If you have two different types of atoms involved in a bond, you can donate the electrons of one atom by dots and the electrons of the other atom by x's. But here we have the same kind of atoms involved, so we're going to use the same kind of notation, which are dots. So when they combine this, we show the combination by the intersection. So we're going to show the shells overlapping like this, and then in between we're going to show the electrons that have been shared. So this hydrogen has 2 and this hydrogen atom has 2. Therefore, they are stable, and this is a bond. The next is formation of water molecule. So water molecule has the chemical formula H2O, and its nuclide notation is 16-8. The 8 is the proton number, which is also a representative of the number of electrons it has. Hydrogen, the electronic configuration is 1. Then for oxygen, which has 8 electrons, the electronic configuration is 2, 6. Hydrogen needs 1 electron to be stable. Oxygen needs 2 electrons to be stable. So how is a bond formed between these two? This oxygen, which needs 2 electrons, can only form a bond when there are 2 hydrogen atoms, because hydrogen is going to contribute 1. If hydrogen contributes 1 to oxygen, oxygen is going to have 7. It needs 8. So it needs 2 contributions, each coming from each of the hydrogen atoms. So one of the hydrogen atoms is going to donate 1, and the other hydrogen atom is going to donate 1. And therefore oxygen is going to have 8. And in the process, oxygen is also going to donate 1 electron to hydrogen and another electron to the other hydrogen, making hydrogen also stable. So this is what I'm saying. So oxygen, which has 6, is going to give one electron to one hydrogen and 1 electron to another hydrogen. And hydrogen is also going to give 1 electron to oxygen, and this other hydrogen is going to do the same. Therefore, hydrogen is stable because it has 2. Hydrogen is also stable because it has 2. Oxygen, remember, had 6. If it has contributed 1, 1, it means it has 4. The other 4 which do not participate in bonding, we don't show them here. So the invisible 4 that are not shown plus the 4 that are in the bonds, oxygen has 8 electrons and it is stable. So we represent again the electrons by bonds, these single lines: 2 electrons, 1, 9, 2 electrons, 1, 9. So this is the structure of H2O. And the balanced chemical equation is oxygen plus 2 hydrogen makes H2O. 2 represents 2 hydrogen atoms that are involved. The visual representation of what happens is this. So hydrogen represented by this kind of electron, and oxygen with its 6 electrons and another hydrogen here. So this is the point that I had emphasized, that we show only outermost electrons. Oxygen has got electrons inside these 2 here, but we're not going to show them because we're only concerned with what happens in the shell that takes part in bonding. So this is the point that I had said. The other point is oxygen electrons are represented by X, and hydrogen electrons are represented by dots. So when they combine, we show the combination by intersection or overlapping of the shells, and inside the overlaps or the intersection, we show the electrons that have been shared. So hydrogen has 2, 1, 2, and this hydrogen has 2, 1, 2. Oxygen has 8, 1, 2, 3, 4, 5, 6, 7, 8. So oxygen is balanced, or it is stable, I mean, and hydrogen is also stable, and water is formed in this way. Another example is formation of carbon dioxide. So carbon dioxide, its chemical formula is CO2, and oxygen, we already know the electronic configuration, but for carbon it's 12,6. So carbon, the electronic configuration is therefore 2,4. Sorry, I use the word electronic configuration instead of nuclide notation here. Yes, but its electronic configuration for carbon is 2,4. Okay, so it has 4 electrons in its outermost shell, while oxygen has 6 electrons in its outermost shell. How can these two form a bond? Carbon needs 4 electrons to be stable. Oxygen needs 2 electrons to be stable. So a bond can only be formed if there are 2 oxygen atoms, and each of the 2 oxygen atoms contributes 2 electrons, meaning that carbon is going to receive 4 electrons, and it's going to be stable because it has 4 already. And in the process, carbon is going to give 2 electrons to one of the oxygen atoms and 2 electrons to one of the oxygen atoms, making oxygen to have 8 electrons in its outermost shell. So this is what I'm talking about. So carbon will give 2, and carbon will give 2, and oxygen also is going to give 2, and oxygen is going to give 2. One thing you should have to keep in mind is, in sharing, both of the atoms that are involved are supposed to contribute equal number of electrons. So oxygen has contributed 2, carbon 2, and the same has happened here. So this is how the electrons are shared. So in terms of covalent bonds, remember 2 electrons represent 1 bond. So here there are 4, meaning that there are 2 bonds, and here there are 4, it means there are 2 bonds, and we can represent this by this. So this is the structure of carbon dioxide. So the balanced chemical equation is carbon reacts with 2 oxygens to give carbon dioxide, or carbon O2. So in summary, the 2 pairs of electrons are shared between a carbon atom and each oxygen atom, and a double covalent bond is formed. The visual representation is this: carbon with its 4 electrons and oxygen with its 6. Oxygen is going to contribute 2, carbon is also going to contribute 2, and the same is going to happen this side, and we're going to have this. So this is carbon dioxide. Finally, we're going to take a look at ammonia. So ammonia, the chemical formula is NH3, and here hydrogen already know information about it, but nitrogen has the nuclide notation 15,7. So this 7 means 7 is the proton number, which denotes the number of protons and also the number of electrons. So we can write the electronic configuration for nitrogen as having 2 electrons in the first shell and 5 electrons in the second shell. So how does an atom with 5 electrons in its outermost shell form a bond with an atom that has 1 electron in its outermost shell? So this element needs 1 electron, well, nitrogen needs 3. Hydrogen needs 1, nitrogen needs 3 to be stable. So the only way a bond can be formed is if there are 3 hydrogen each should be contributing 1 electron to nitrogen, and in the process nitrogen is going to give them 1 each, and they are going to be stable, and nitrogen is going to be stable like so. Before I can even show you, the summary is ammonia is formed from bonding between 1 nitrogen atom and 3 hydrogen atoms. So this is what happens here. So nitrogen has 5 electrons in its outermost shell, hydrogen has 1, hydrogen has 1, hydrogen has 1. So if nitrogen contributes 1, hydrogen is going to be stable, and 1 hydrogen is going to be stable, and 1 hydrogen is going to be stable. What about nitrogen? Is it going to be stable in hydrogen? Each of the hydrogen contributes 1 electron to form this compound here. So if you count the number of electrons in nitrogen, there are 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Therefore, nitrogen is stable. And this is how ammonia is formed. So we finish up on covalent bonds by taking a look at characteristics of covalent compounds. 1, they are made up of molecules. 2, they have low melting and boiling points because of the weak forces of attraction which holds the molecules. An example of a covalent compound is a plastic. So plastics have got low melting and boiling points. Reason is because they have weak forces of attraction which holds the molecules, unlike ionic bonds. 3, they are insoluble in water but soluble in organic solvents such as ethanol and petrol. So plastic is insoluble in water, but it's insoluble in other type of solvents, which are organic solvents. 4, they do not conduct electricity in solid or solution form because they are made up of molecules. So ions, ionic compounds have got ions which help in the conduction of electricity, but molecules do not conduct electricity. Therefore, covalent compounds do not conduct electricity. Finally, they are generally volatile, meaning that they easily evaporate. We finish up the discussion with metallic bonding. So what is metallic bonding? This is the third type of bonding, and metallic bonding is the attraction between the positively charged metal ions and the free electrons in a metal lattice. So lattice is structure. So what this means is when we have a metal, or maybe more than one metallic atoms, if the electrons, the outermost electrons are lost, then there will be attraction between the lost outermost electrons and the positively charged nucleus. Remember, if an atom loses an electron, this nucleus is going to have a charge of positive because it has one more proton than electrons. So let me just demonstrate that further. But before I do that, here is one point that I want you to keep in mind. Maybe should I say, here are some points. It involves the sea of electrons around positively charged particles inside the metal structure. A sea of electrons is means a body of electrons, or a lot of electrons surrounding a positively charged particles, or the nucleus. So they are all trapped in a metal structure. The electrons are free to move anywhere in the metal lattice. The electrons are said to be delocalized. So these electrons in the sea of electrons are free to move anywhere so long as it is within that metallic structure. The electrons, because they are free to move, they are said to be delocalized, meaning that they are not localized, or they are not positioned at one point. This gives metals the property of being good conductors of electricity. So metals are good conductors of electricity because of this sea of delocalized electrons. So let me just demonstrate. If we have one metallic atom and it loses an electron, then it will be like this, and another will be like this. So if we have a lot of these metallic atoms which are losing outermost electrons, we're going to have something like this. So there will be two types of particles inside this metal lattice, and that is there will be positive charged particles and negative charged particles, and they will be attracted to each other. But the electrons will be able to be moving around. Because of these delocalized or mobile electrons, metals are good conductors of electricity. Electricity is just the movement of electrons in a substance. So these are free to move. Therefore, this gives metals the property of being good conductors of electricity. So this marks the end of this topic, bonding. Of course, metallic bonding is simple. We didn't tackle it like the rest. And one property of substances that results because of metallic bonding is this, being good conductors of electricity. And if you have been asked why, it's because of the sea of delocalized electrons. This marks the end of this topic. Hope you have enjoyed. Happy solving.